Hello friends. Now next topic is electronic instrumentation. Now in this topic we will discuss about the different electronic measuring instruments like first digital multimeter, second function generator, then digital storage oscilloscope, that is DSO, then next AC DC power supply, then next analog ammeter and voltmeter. Now in this lecture we will discuss the first topic, that is digital multimeter. Now learning outcomes. Now after studying digital multimeter, students will be able to understand what is DMM, which are the different features of DMM, then next the block diagram of digital multimeter, then next which are the different symbols which are available on digital multimeter, then advantages of DMM over analog multimeter, then next which are the different disadvantages of DMM, and last which are the different applications of DMM. Now, what is DMM? Now, the DMM or digital multimeter is an instrument that can measure the DC voltage, AC voltage, DC current, AC current, resistance, conductance, decibels, and it displays the measured quantity digitally. That's why it is called as a multimeter, because by using this meter we can calculate or we can measure the different electrical parameters like DC voltage, DC current, resistance or conductance. Now some DMMs are capable of measuring the different physical quantities like temperature or frequency, etc. Now which are the different features of DMM? Now first, it is light in weight. Second, it is capable of giving more accurate readings. Then next, it measures many physical quantities like voltage, current, resistance, frequency, etc. It is less costly and it measures the different electrical parameters at high frequencies with the help of special probes. Now let's see the block diagram of digital multimeter. Now figure shows the simplified block diagram of digital multimeter. As shown, it consists of the following blocks. First, DC attenuator, then next rectifier and attenuator, then next current to voltage converter, then next resistance to voltage converter, then analog to digital converter, that is ADC, and counter and digital display. Now to understand the working or to understand the block diagram of DMM, there are two test probes that are to be connected to the 2 points between which the measurement of voltage, that will be either AC or DC, then next DC current or resistance, is to be made. The positive probe, that is red probe, is connected to the function selector switch, which is positioned appropriately to the measured desired quantity. Now first, DC voltage attenuator. Now this is basically a resistive potential divider with multiple resistors connected in series between the inputs and the ground points. The function of this block is to attenuate. Now what is meant by attenuate? To reduce the amplitude. To attenuate the DC voltage applied at its input and connect the attenuated DC voltage to the ADC, that is analog to digital converter. A rotary switch, which is used as a voltage range selector, it decides the amount of attenuation provided to the input signal. Now second block, that is rectifier and attenuator. An AC voltage which is to be measured is applied to this block via function selector switch. Means if we change the position of function selection switch to the AC voltage, then this block will be active. Now this block rectifies the AC input voltage and attenuates it to an appropriate lower value with the help of potential divider and a voltage range selector switch. Now the rectified and attenuated voltage is applied to the ADC input, that is analog to digital converter input. Now third block, current to voltage converter. Now the DC current which is to be measured is applied to this block via the function selector switch. Same, if suppose we change the position of switch to the DC current, then it will measure the DC current. Now the DC or unknown current at the input is passed through a known resistance to produce a DC voltage across it, and that is proportional to the DC unknown current, and this voltage is applied at the input of the ADC block. Now next, the resistance to voltage converter. Now the input probes is connected to this block via the function selector switch. Now a known DC current from constant current source is passed through the unknown resistance to produce a DC voltage proportional to the resistance value. Now this voltage is applied at the input of ADC block, that is analog to digital converter block. Now next, important thing, how to convert this analog signal into digital signal, because to display our reading it is digitally, so we need to convert that analog signal into a digital. That's why this block is very important. Now what is the working of ADC block? The ADC block converts the analog DC voltage at its input into a proportional digital number. Now this digital number is applied to a counter. Now what is counter and display? The digital number from analog to digital converter or ADC is applied to the counter input. It acts as a reference number with which the counter output is compared continuously. Now the time taken by the counter output to reach the ADC output value is measured and displayed on 7-segment digital display. Thus, the quantity to be measured is displayed in the digital form. Now, this is the simplest working of digital multimeter. Now next, which are the different symbols are available on digital multimeter? Now let's see, there are mainly 9 symbols which are available on any multimeter. Now let's see first symbol. Now first symbol indicates the AC voltage. Now this measures the amount of AC voltage, means if suppose the position of rotary switch is at AC voltage, means this symbol will indicate we are going to measure AC voltage. Now if we change the position of rotary switch, then second symbol indicates its DC voltage. Now this will measure the amount of DC voltage. Now third symbol, hertz. Hertz means it measures the frequency. As we know, the hertz is the unit of frequency. Now fourth symbol, ohms, means it measures the values of resistance. Then next, fifth, diode. Fifth symbol indicates diode. Now this device is used to control the direction of flow of current. Now sixth symbol, that is microfarad. Now microfarad, it indicates the, as we know, the microfarad is the unit of capacitor, means to measure the value of electrolytic capacitor, we will require this symbol, that is microfarad. Then next, ampere, it measures the amount of electron flow, means it measures the current which is in ampere. Then next, eighth, now this symbol indicates the ground. Now it is generally used to grounding the device, means generally as we know, there are 2 probes are available for digital multimeter, that is first one is your red probe and second one is your black probe. Your black probe is compulsory connected with the ground, while your red probe is connected with the functions which are we are going to calculate. It will be either AC voltage, DC voltage, or values of resistance, or the diode, or means remaining parameters. Means your black probe of your digital multimeter is compulsory connected with the ground potential. Then next, last symbol, that indicates the continuity. Now it indicates the audible indication of continuity for the low resistance. Now these are the means commonly symbols which are available on each digital multimeter. Now some multimeters having temperature. Now if suppose that we are going to measure the temperature, then it indicates the degree Celsius, means it's a unit. Now next, which are the different advantages of digital multimeter over analog multimeter? Now first important advantage, high accuracy due to digital display. Then second, automatic range selection. Then next, multiple parameters which we can measure by using one instrument. As we know, we can measure AC voltage, DC voltage, the next AC current, DC current, the next values of resistor. Means these are the different parameters which we can measure by using one instrument, that is digital multimeter. And last advantage over the analog multimeter is that high input impedance which eliminates the source loading. Now which are the different disadvantages? Now first, only two disadvantages are there. First, a battery required to be used. Then next, it is costlier than the analog multimeters. Then next, which are the different applications of digital multimeter? First, it can measure AC or DC voltage. Then next, it can measure AC or DC current. Then next, it can measure the resistance. Then next, to test diode or transistor, digital multimeter is used. Now these are the different applications of digital multimeter. Thank you.